Okay, so today we're going to be talking about how do you solve a right triangle. Okay, and so if you're solving an equation, you're trying to find the value of x. Okay, or if it's a more complex equation, maybe both x and y. If you're solving a triangle, you want to find the value of all the parts of the triangle. That means the three sides and the three angles of said triangle. Okay, so, and we want to make it as precise as possible. And so it's going to take us a couple steps to figure out how do we do that? What is the appropriate, method to find the answers to these problems? So the first thing is a little bit of review. Okay, so if I say, what is the sine of 30 degrees? I would love you to go to a live triangle and find the value of the ratio of the opposite leg over the hypotenuse. So if you look at this triangle on the right, you would do the opposite leg of the 30-degree angle, and you would say it's s over 2s. You could reduce that, and it would be 1/2. And the next thing is the cosine of a 30-degree angle. Okay, so again, that's adjacent leg over the hypotenuse. So that would be s root 3 over the hypotenuse, which is 2s. The s is reduced. And for some reason, they use s's on these problems, but you could use x instead. Okay, and so that would be the square root of 3 over 2. You could also use any 30, 60, 90 triangle because the ratios of those appropriate sides will all yield the same values because they're all similar to each other. They're all proportional. Okay, the tangent of 45. If you write the opposite leg over the adjacent leg, you're going to get s over s, or you're going to get 1. Okay, and so these are three values that we found before. You could find a lot of other things. Now, I want you to look at the line below it, okay? It says, find the value of theta. Okay, we're kind of working backwards to think about, okay, the sine of a specific angle has a numerical value of 1/2. What is the measure of angle theta? Well, look up above. We just did that same question. We said, hey, sine of 30 gives you 1/2. So if I play dumb, or if in a couple of years they're like, let's quiz kids and see, which angle gives you the answer of 1/2. And the truth is they will at some point, not this year, but at some point they will. And so you're like, okay, well, that theta is absolutely a 30-degree angle. Okay, so again, we're trying to play on what will they ask you in a couple of years. Tangent of which angle has a ratio of 1. And the theta, the only one that works, is 45 degrees. Okay, who has a sine of the square root of 2 over 2? You're like, I don't know. Well, go up to, we know it's not 30. And we actually know it's not 60, okay, because those are 1/2 and the square root of 3 over 2. Who has a sine of the square root of 2 over 2? It's got to be 45. Try it. If you do opposite over hypotenuse on a 45, reduce it and rationalize it. Okay, you've got to times it by the square root of 2 over 2. The square root of 2 and the square root of 2. You get square root of 2 over 2. So that is going to be a 45-degree angle. Okay, so theta is equal to 45 degrees. So if I ask you to find the measure of theta, you could hypothetically kind of know it or look at a triangle and be like, let's see if we can figure out which one has that ratio and kind of work backwards like a little fun game. Now, the other deal is this. Sometimes you're like, I don't feel like playing that game, or they ask you a really hard question that really nobody knows. Okay, and so you're like, how can I use my calculator to help me solve this equation? Well, I think the first thing is we've got to think about, when you're solving a regular equation, if something's added, the inverse of adding is subtracting. The inverse of multiplication is division. The inverse of squaring is square rooting. So you've done all those inverse operations to help you solve. And here is a similar situation. Okay, let's look at it. In this next question, it says sine of an angle, theta, is equal to 3/4. And in, more basic kind of question, you've solved 2x is equal to 10, and you're like, oh, 2 times x. So I have to untime, so I'm going to divide. That's how you get rid of the 2. And so x is equal to 5. Well, sine of theta doesn't mean sine times theta. Okay, of does not, it a lot of times does mean times, but it does not in this case. And so the question is, how do you get rid of the sine in front of the theta? You have to unsign it. Okay, well, what is that? Okay, well, the truth is the inverse of this, okay, and you're going to learn inverses next year, okay, is you're going to do sine to the -1, okay? It's not -1. It just means literally unsign, okay? And so if you do sine and unsign, they just leave you theta. But in math, if you do it to one side, you have to do it to the other side as well. Okay, so I did it to the left side, and I've got to do it to the other side as well. So theta is equal to the inverse sine of 3/4. So what you're going to type in your calculator is that inverse sine. Well, where is it? Well, conveniently, okay, most inverse operations are actually using the same key on your calculator, but you just have to push like second first. So if you do second and then you do sine, you'll notice you see this little figure right here. And if you type that in your calculator, you're going to get theta is going to be approximately, because we're going to have to round, okay, it's not a nice value, is approximately 48.59 degrees. Okay, so that's how you unsign something. If you're like, I want theta by herself, well, look at the next one. Okay, let's try this one. You might know the answer to this one. On the other hand, you're like, I don't know, I want to use my calculator if I can. Okay, so let's do that. So if you're going to use your calculator for this one, we're going to say, if I want to get rid of tangent, I have to untangent it. Okay, so let's do tangent inverse. Okay, so that gets rid of this tangent. So that means theta, but if you do it to one side, you better do it to the other side. Okay, so if you want to get rid of the tan, you want just plain old theta, do the inverse tangent. So do this to both sides, and your answer is going to be 30 degrees. So that means if we went up to our special right triangle and we found the tangent, we would get square root of 3/3. Okay, so your calc does know this as well. And the older you get, the more you'll realize sometimes it's smarter to use a calc, sometimes you really shouldn't. All right, if I want plain old theta, I have to uncosine this. So let's uncosine this, and we're going to do the inverse cosine. Okay, that's how you uncosine something. And that cancels these out. And then on the right-hand side, you're going to do the inverse cosine on this side. And if you type that right side in your calculator, you get theta is approximately 45.57. And that's in degrees. Okay. And the last one here, sine of this. Now you might remember it's going to be 45 degrees, but if you don't remember it and you want to use your calculator instead, you have to get rid of sine. How do you get rid of sine? You inverse sine. Okay, so inverse sine of the left side gets rid of sine. If you do the same thing to the right side of the equation, and you type that in your calculator, make sure you close the parentheses, use a fraction, do all the good things, check to see if you get 45 degrees. If you don't close the parentheses or you don't type it in right, you're going to get a different answer. It really is 45 degrees. So talk to me if you're like, my calc is actually not. Now, I want to remind you that oftentimes we use our calculator for hard problems. And that would be the examples below. You know, you're like, what is the cosine of 78 degrees? Well, if you don't have a live 78-degree triangle on you, okay, you're like, oh, I know the ratios. How are you supposed to find the answer to a 78-degree triangle, find its cosine, if you don't know any of the sides, okay? It's not special, so you can't just write. You don't have one on hand. So if you don't have a live triangle or you can't come up with a live triangle, well, then use your calculator to approximate this value. And so this is going to be about 0.21. Okay, sine of 30, you may know that is 0.5 or a half. 45 is going to be 1. Okay, and you may know it or you may need to use your calculator. It's kind of up to you on some of these questions that could go either way. I don't know the tangent of 23 degrees. I don't have a triangle sitting around, so I'm going to use my calc. So 0.42. Okay, that's what that says. Okay. And then the next one is just basically saying, how would you evaluate what is shown here? Okay, do you know how to do those buttons? Okay, and so if you literally do second sine and do the inverse sine of 0.85, it's going to give you the degree who has the sine value of 0.85. So this would be, it says give it to the nearest degree, so this would be 58 and then be degrees. Okay, if you do inverse cosine or inverse sine or inverse tangent, you're going to get an angle. Okay, it's like, tell me whose angle gives this answer for cosine. Okay, and so this would be about 52 degrees. And the last one is going to be 74 degrees about. Okay. All right, all that being said, now let's start solving some problems, okay? And so we're not going to solve the entire triangle yet. We're going to work our way out, okay? So what we need to remember is we've got three trigonometric, ratios that we can use, okay, equations that we can put into play and say, okay, we've got sine of theta is equal to opposite over hypotenuse. We've got cosine of theta is equal to adjacent over hypotenuse. And we've got tangent of theta is going to be opposite over adjacent. Okay? So, which one are we going to do? Okay, how are we going to do this? Well, mark what you know with perspective to the angle of which they speak. Okay, so the angle we know is here. Okay, so she's theta. So they gave us the value of theta, so that's kind of cool. And according to that angle, we also are talking about the opposite side, and we're going to be talking about the hypotenuse. So some kids find it helpful to write down, this is the opposite side, and this is hypotenuse. Which trig ratio talks about the opposite side and the hypotenuse with an angle? That would be sine. Okay, so you could say the sine, we know the angle is 42 degrees, equals x over 10. Okay, the opposite leg over the hypotenuse. And so solve for the x that you don't know by multiplying both sides by 10. Cancels it on the left side, or on the right side. And then on the left side, we would just evaluate 10 times the sine of 42 in our calculators, and x is approximately, and since it's a length, okay, you should label it 6.69 units, okay? In the next question, again, the theta, we don't know it. So that's actually going to be our variable, okay? And then we also have the opposite side of that angle, the opposite leg, and we're also speaking of the hypotenuse, okay? So which trigonometric ratio talks about, from an angle's perspective, the opposite of the hypotenuse? Again, it's sine. So we're going to say sine of theta, that's our variable, is equal to 7 over 11. You're like, how do you solve this? Well, if you want to find theta, you have to get rid of the sine. How do you unsign something? We're going to do the inverse sign of both sides of the equation. So that cancels out that sine. You end up with theta. On the right side, you're going to do inverse sine of 7/11. If you type that in your calculator, so do inverse sine of 7/11, close the parenthesis, use a fraction or a division key, but close the parenthesis, and you're going to get approximately 39.5, and that's going to be degrees. Always label your answer. If it's an angle, label it in degrees. If it's a length, label it in terms of the units of which they speak. Okay, so I hope you're hanging in there. The next question says, find x. Okay, well, it appears that that's the adjacent leg, and this is the opposite leg. So we're going to use tangent, okay, according to this angle here. So tangent of 31 degrees is equal to the opposite leg over the adjacent leg. Okay, so that makes sense. We know the opposite, we know the adjacent, and we know a theta. Okay, so that's what I plugged in. Okay, the best way to do this is do the little switcheroo. So we're going to switch these values, the tangent of 31 with x. So x is equal to the quotient of 43 over tangent of 31. Find that quotient. X is approximately 71.6 centimeters. Okay, let's check out the next one. In the next one, the theta is the variable we don't know, but compared to theta, we are talking about the adjacent leg and the hypotenuse. It's really important to know what are the names in respect to the angle of which you speak. So the adjacent leg and the hypotenuse. And so this would be cosine. So cosine of an angle is equal to the adjacent leg over the hypotenuse. We want theta by herself. So to solve this, we have to uncosine the left side. And then that gives you theta. So if you do it to the left side, you have to do it to the right. Type inverse cosine, 12 divided by 18, close the parenthesis. Okay, your answer should be about 48.2 degrees. Okay, check and see. Is your calc working right? Is it misbehaving? How are you doing? Okay, last one. Here's our theta. Okay, we're looking for to find the measure of theta. And which trig ratio are we using in this problem? Well, the two sides we know are the opposite leg and the adjacent leg. So if you know both legs, it's going to be tangent. So it's going to be tangent from theta's perspective. We don't know the value of theta is equal to the opposite leg over the adjacent leg. Okay, to get the theta by herself, you want to untangent both sides. And so theta is equal to the inverse tangent of 16 over 6. And that theta is about 69.4 degrees. Always label your answer. Okay, if it's an angle, do degrees. If it's a measurement, do units. Okay, the next thing is kind of foreshadowing what we're doing on the next side. Okay, when I ask you to solve an equation, I want you to find the values of x. When I say solve a triangle, you're going to find all the missing sides and all the missing angles. And the rule that I would say is this. You can only, in every single equation you do, you're only allowed to use the given values. Okay, so you can't rely upon something you've solved for halfway through the question. So if you're like, I did the Pythagorean theorem and found a missing side, I'm going to use that to find something else. No, I only want you to use in every single step only given data to find that next value. Okay, so that's going to be kind of the trick, is like only use given data to find the missing parts. Okay, and so here we go. So this is solve this. The given data, we're given three things. We're given the measure of this segment here, the hypotenuse. We're given the measure of this side right here, and we're given that it's a right triangle. So those are the only three things that we're allowed to use in any step to solve a problem. Okay, so now when they do it like this, we already know something. So we know AC, the length of it is going to be 5 centimeters. We know that BA is going to be 5.7 centimeters. And we know the measure of angle C is going to be 90 degrees. So those are things that are given. Okay. Now, to find the last three things, you can only use given data in each step. So the first thing I'm going to do is say, let's find BC. You always start with a thing that you're given two of. I'll either give you two angles or two sides. Okay, and so you've got to use those two things to find the third of that set. Okay, so if I give you two sides, how could you use two sides to find the length of the third side? Well, you have to use the Pythagorean theorem. Okay, so to find CB, I'm going to organize my work. I'm going to say I'm going to do 5 squared plus CB squared, or you could do x squared, doesn't matter, or b squared, whatever you want to call it, equals 5.7 squared. And then you're going to solve this, okay? And I'm going to get 25. I'm going to get 5.7 squared. And I'm going to minus 5 squared from both sides. Now, technically, you can do CB squared is equal, and you could put 5.7 squared, subtract 5 squared, and it will give you CB squared. You just have to take the square root of that answer. And then when you take the square root of that answer, you're going to get 2.74. So CB is approximately 2.74. And that is going to be centimeters. Okay, and so I'll tell you how I put it in my calculator. Where's my calculator? Here she is. Okay, I just typed in 5.7 squared and then subtract 5 squared, and then I pushed enter. Okay, and then I did second square root, and then I arrowed up and got that value. Okay, and then I pushed enter, and that gave me the square root of that answer. So let's see if I can do it right here. 5.7 squared minus 5 squared equals a 7.49. And then I have to do second square root, second answer, and I get 2.7367, blah, blah, blah. Okay, so that would be 2.74 centimeters. That's approximately. And then I've got to find the measure of each of the other angles. Okay, and so again, you're only allowed to use given data to find each of those answers. So if you want to find the measure of angle A, okay, you're going to say that theta, okay, our measure of A, is going to equal, if that's using cosine, it's going to be I know the adjacent leg and I know the hypotenuse. Okay, so that would be cosine from A's perspective equals 5 over 5.7. If I want to find the measure of angle A, I'm going to do the inverse cosine of both sides. And that'll cancel out that cosine. And I've got to do it to the other side. If I put that in my calculator, I'm going to get the measure of angle A to be 28.7 degrees. Okay, so that would be to find the measure of angle A. Now, technically, we could find the answer to angle B just using that rounded off data and be like, hey, I bet you it's right. But what is a smarter choice is to say, you know what? And what I want you to do is say, let's find this other angle B. And let's use trigonometry to find it. So to find angle B, again, with every step, you're only always allowed to use the given data. Okay, 28.7 degrees was not given data. So if you rely on it to find the next step, that's not okay. So we're going to say from B's perspective, this is the opposite side and this is hypotenuse. So it's going to be sine from B's perspective is equal to 5 over 5.7. If you do the inverse sine of both sides, you get B is equal to the inverse sine of 5 over 5.7. So use your calculator, do inverse sine of that. Second sine. And then I'm going to do 5 divided by 5.7, close the parenthesis, and I'm going to get 61.3. Now, if I did it right, the sum of these angles should make 180 degrees. And it does. Okay, if I add those up, I am going to get 180 degrees. So I did a good job. So one of the rules of solving a triangle is to only use the given data at every step. Okay, only use the given data at every step so you can be most precise. And if you did it right, then it's going to work. So on this one, our given data is as shown. I know this is a right angle, I know the side, and I know this angle right here. Now, your first thing is going to be use the thing that you know 2 of to find the third of that value. I don't know 2 sides, but notice you do know 2 angles. So if you want to find the measure of angle P, you can use the 2 given angles to find the third one. So you could do 180 minus 90 and 68, or you could do these 2 angles have to be complementary to each other. So 90 minus 68. So 90 minus 68. Make sure you show your work. Okay. 90 minus 68. You're only allowed to use given data, and we know 2 out of 3 angles, so we can use the triangle sum theorem to be able to say this is what the other one is. So this is going to be equals 22 degrees. Okay. The next thing is we need to find, so I'm going to put 22 degrees, but we can't use that in the rest of this question. We're just going to keep that as a data point. We need to find PQ and we need to find PR. Okay, and so let's find PQ. So to find PQ, I'm going to call that X, okay, and compared to the angle they're given is 68 degrees, that's going to be the opposite leg, and we know the adjacent. So we're going to use tangent, okay? So tangent of 68 degrees, because it talks about the angle and the 2 sides, one that we know, the one that we don't, is equal to X over 20, multiply both sides by 20, and so PQ is approximately the product of this times 20, multiply both sides by 20. It cancels out on this side. You have to multiply this side by 20. So you do 20 tangent of 68. You're going to get 49.5. And that is going to be meters. Okay. And then we also want to find PR. And so we can call that Y. And using our given data, that's going to be the hypotenuse. So we're going to use cosine. So the cosine of the angle we know, which is 68, equals the adjacent leg, which is 20, over the hypotenuse, who is Y. The best way to solve this is Y is equal to 20 over cosine of 68. If you find that quotient, that means that PR's length is equal to approximately 53.4. And that is going to be meters. Okay, so if you look at this, we used our 3 given data sets. Okay, we know an angle, there's a right angle, and we know one side. We used, on every step, we only use given data to find our missing parts. Okay, we've got, looks like 4 more questions. Woo, here we go. It says, if you're given these vertices, okay, -1, 2, that's D, and you're given -1, -3, that's E, and 3, -3. Can you find the length of all 3 sides and the measure of each angle? All right, let's do it. And so we know that DE, okay, if we count it, is going to equal, let's see, 1, 2, 3, 4, 5, 5 units. And we know that EF, if we count it, is equal to 1, 2, 3, 4 units. And then we know that the measure of angle E equals 90 degrees. Okay, we can see that. And then we got to find a DF. And to do that, we're going to do 5 squared plus 4 squared equals C squared. If you square those and add them up and then take their square root, you're going to get the value of approximately 6.4. Okay. And then to find the measure of the missing angles, okay, let's find the measure of angle F. And then we're going to find the measure of angle D. And we're going to use only given data as we go. So angle F. Okay, so let's do this. We're going to say, I know the legs, okay? The hypotenuse is kind of a janky decimal, so we're not going to use her. So tangent of F's perspective is equal to DE, which this right here is 1, 2, 3, 4, 5. Over the adjacent, which is 1, 2, 3, 4. To find the value of F, we're going to say F is equal to the inverse tangent of both sides. If you put that in your calculator, you're going to get measure of angle F is approximately 51.3 degrees. Okay, so this is our work that we did. And then the last step is going to be the measure of angle D. Okay, so that's up here. And so tangent from angle D's perspective is going to be 4/5. And so if you want to find the value of D, you're going to inverse tangent both sides. So D is equal to the inverse tangent of 4/5. If you put that in your calculator, you're going to get it equal to 38.7 degrees, approximately. Now, if you add up all 3 angles, you should get 180 degrees. And there you go. We solved all the triangle by finding the measure of all 3 sides. 2 of them we counted. The third one, we did the Pythagorean theorem. We could have done the distance formula if we needed to, but we didn't really need to. Okay, and so we did counting and then the Pythagorean theorem to find the angles. We used inverse trigonometry. Okay, and what acute angle does this make with the x-axis? Okay, so to find this angle, we need to know the length of 2 of the sides. Okay, and then do inverse. So with they want this angle here. So if you want this theta right there, we know this length is from here to here is 16 units. And from here to here is going to be 24 units. So tangent, those are the legs that we know, the opposite over the adjacent. And to solve for tangent or for theta, we're going to do inverse tangent to get rid of the tan. So theta is equal to the inverse tangent of 16 over 24. Use your calculator because I don't know that off the top of my head. So theta is about equal to 33.7 degrees. All right, moving smoothly along. They're talking about how steep is a grade, okay? And so if you go to the mountains, they oftentimes will give you the grade of the road, and it's kind of out of 100. So the grade is the rise over the run. So this is 8 feet for every 100 feet here. Okay. And so what they want you to do is how many degrees would this theta be? Okay. So tangent of this theta is equal to 8 out of 100. To solve it for theta, you're going to inverse tangent both sides. And so you get theta is equal to the inverse tangent of 8 over 100. And then if you did that on your calculator, you're going to get theta is approximately 44.57 degrees. Okay. And the last question, okay, in the last question, the road sign shows a steep grade of 14%. 14% means 14 out of 100. Okay, so that means 14 over 100 is the slope. Okay, what is the theta of that? Okay, what is the angle that it makes with the line? And so we would do tangent of theta is equal to 14 over 100. To solve it, you're going to do inverse tangent of both sides. So theta is equal to the inverse tangent of 14 out of 100. Use your calc. Theta is approximately 7.97 degrees. All right, so we're learning how to use sine, cosine, and tangent in lots of ways. Thank you so much. Have a good day.